Hi, today I'm going to code some examples to show how you write code that deals with rectangular arrays and jagged arrays. First, let's play with rectangular arrays, and let's say that the example is football statistics. So I want to keep track of how many passing yards there are in every quarter of every game in a season, so that I can draw some conclusions, like how many passing yards did the team get in a game, and on average, how many do they get in a particular quarter. So for that, I need a rectangular array, and I want it to have one column for every quarter and one row for every game. And then I'll do some statistics on yards per quarter and yards per game, passing yards per quarter and passing yards per game. So the first thing that I have to think about is I have to think about how am I going to test what I'm going to do. I'm going to need a two-dimensional array that has some specific data in it so that I can pass that into the functions that are going to do the calculations and make sure that I get the results that I want back. So I would like a rectangular array that I could just write some loops to fill it in, but I'd like every position to have a value that is unique, so it's the only one in the array that has that value, and that from the value I can calculate where it ought to be, because that'll make it easy to debug. If I read something out of the array and it isn't the value that I expect it to be, I can tell where I read from the array. So I'd like to set up the array to look like this. Obviously, these are not real statistics from a real football game, but what I've done is every position is the row number times 10 plus the column number. So if I got one of these numbers, like if I read a 111 out of this array, I could divide it by 10 and get which row it had been in. And I can mod it by 10 to get which column it should have been in. So the first thing I want to do is I want to make a project, and I want to have my main method, which is going to test the stuff that I'm going to build. I want to make it have this array so that then I can pass this into the things that I'm going to build and make sure that they give me back the value that I ought to get back. So to do that, I'm going to make a new project in CLion. It's a C executable, and I want a new folder for it that is rectangular, well, 2D arrays. Let's do 2D arrays. Come on, come on. There we go. 2D arrays. Okay, so in this project, it's a normal project. I just have a main. In my main, I want to declare a 2D array that I'm going to call season, that should have one row for every game and one column for every quarter. And I'm going to make those be constants because we should not hard code how many games or how many. I don't want to create a variable. I want to create a macro, num games. There should be 14 games in a season because that's a good season length. And I want to create a macro, num quarters. There should be 4 quarters in a game. I don't need to print out hello world. So now I want to build that. I want to put that data into season. So I'm going to walk through the games. Ooh, not I. Game less than games. Games plus. So those nested loops are going to walk through the number of games and the number of quarters. So if I were to think about this example, this game variable is walking from 0 to 14. So it's walking down. But inside that, for each row, it is the quarter variable is walking across. So the order that this nested loops will fill this in is it'll go across the first row, and then it'll go across the second row, and then it'll go across the third row, and so on. And inside each one, I want to set the thing in that position to be the game number times 10 plus the quarter number. So that's exactly what I did in this, where this, the formula for this is the game number times 10 plus the quarter number. So at the end of that loop, I will have built that rectangular two-dimensional array, 14 rows, 4 columns. So I have that so that now I can write some tests. What I want to build is I want to build a set of functions that do statistics on that array. So that array has in it, presumably, the number of passing yards that we got in each quarter, in each game for the season. So I'm going to make a new C source file called stats, let's say, because it's computing statistics. I want its type to be C, and I want the associated header because I need the associated header. And I'm going to tell it to add it to the executable that I already have in my CMake file. So that creates, yes, add those to Git, go ahead. That creates a stats.h and a stats.c that includes the stats.h. And it makes my CMake have those two files already in it. So just for to show that things are hooked up in here, I could say int silly x. I could just make a silly function, and I could declare that silly function in here and make it just return x plus 2, say. 2. And in my main, I could say assert silly of 4 equals 6. And I'm only doing this so that I can check to make sure that my files are all hooked together correctly. So the first thing that happened that I did really quickly there was the compiler was mad that it couldn't find silly. I let it import it, so it added this include of stats.h that lets me now see what silly is defined to be. And similarly, it's mad that it can't find assert. I'm going to let it import assert from assert.h. So now I have assert. And so if this works, we should call the silly function passing in a 4. It should get back a 6. This is true. So my assert should pass. But test-driven development says that you should make your tests fail before you make them pass. So for a moment, I'm gonna make this fail. Just return x. Now when I run my stuff, that assert in my main should complain. And it does. Look at this. The assertion that equals 6 failed. Woohoo! To make it pass, I put in the real code. And it passes. Now I will admit at this point very little of what I have done in my main has to do with my 2D array thing. What I'm checking first is to make sure that the files that I have created actually talk to each other nicely. So in my main, I can write something that uses code that is defined in my stats with my stats.h. So these three files have been connected to each other properly by that CMake file. Woohoo. I don't really want to build silly, so I'm going to delete that. What I want to do first is I want to make a function that just tells me the total number of passing yards for a particular game. So total number of passing yards is going to be an integer. And I'm going to call it passing yards per game. And I'm going to need to pass in that two-dimensional array and the game that I want it to calculate the statistic for. So I'm going to pass into it data that is num-games by num-quarters. And you can see already it's like mad that num-game and num-quarters doesn't exist, even though we know we do. That's because we need to move them. But hang on a second. I want the first parameter to be my two-dimensional array. I want the second parameter to be which game we're interested in. So that's the function that I want to build. The first thing is I need to get rid of the fact that these are red. We have declared them over here in the main, but they really aren't things that the main node should define. They are things that our stats files should define. So we should define them in this H file, and that way everybody who includes them gets them. So everybody will have them. They're all related to this particular set of functionality. So that's why I want them to be declared in this H file. Okay, now before I actually code this, let's declare it in my C file, and let's just make it return 0. Just so that it exists. Then what I want to do is I want to write a test for it and watch that test fail. And then I want to write the code here that would make the test pass. So in my main.c, I want to assert that if I were to call, what did I call it? This. If I were to call passing yards per game, passing in the season that I have built here, so this two-dimensional array with these magical numbers in them, if I pass in that season and season 0, game 0, then that should equal 0 plus 1 plus 2 plus 3, double equal. Because if I pass in a 0, I want it to add up this row. Okay. I'm missing a semicolon, so put in the semicolon. This should fail because I have not yet built passing yards per game. And it does fail exactly where I wanted it to fail. Now, the easiest way that I can make that test pass is make it return 0 plus 1 plus 2 plus 3. And you think, well, that's really a dumb thing to do. Go with me a second here. I really don't like when stuff is failing. I really like when everything is pretty and you know, everything is passing. So I like go as fast as you can to yay, we got it to pass. That tells me that my assert is actually testing something and that I can make it pass. But then you can see the duplication from here to here. And that duplication tells me I didn't build the real implementation of this. I just built enough to make everything happy. I can make my tests more robust if I say, if I call it for that season, game number 13, which is the last one. So I've already tested this one. Now I want to test this one. Oh, there were only 13. Because I made the number of games be 14, so they're from 0 to 13. So game number 13 in this weird, stupid data should be 130 plus 131 plus 132 plus 133. And that will fail miserably. Boom, it does fail miserably. So now, in order to make both of those asserts pass, I need to write the real code. So I'm going to go to stats. And what I want to do in the real code is I'm given a game number. I want to go to that row of my two-dimensional array and walk across the row, adding them up. So I need a running sum that starts at 0. And then I need a for loop. It's a walking through the array kind of loop. It's a count controlled loop because I know there are always 4 entries. And so I'm going to use a for loop. And I'm walking across quarters. So I'm going to name the variable quarter. Started at 0. While it is less than the number of quarters, increment it. So that will walk across the columns. And what I want to do is I want to add to my running sum the statistic that is in the row that I have been asked for, the game number that was passed into me, and the quarter that as we're looping through. And then I want to return that sum. I can run that and I can guarantee you it's going to pass, but I think we should talk about that a little bit more. Let's put a breakpoint and watch what's actually happening here. So I put a breakpoint here. If I try to look at my data, at this point, it tells me it's a pointer. Because remember, when we pass arrays into something, we don't actually copy the whole thing and pass it into it. We pass a pointer to it. So I can see a pointer here. I can't really look. I can look at the first row, but I can't really look at the whole thing. If I click on the mainframe and I look at it here, it knows that it's a two-dimensional array, and I could look at every row and I could see the 0th row has 0, 1, 2, 3. The 7th row has 7, 71, 72, 73. And the last one has 130, 131, 132, 133. So my data looks right here. When I pass it in here, the first position that I'm going to look at for is at game 0, quarter 0. And that's because the call that we're doing is this one, where we passed in the 0th game. And so we're going to add 0 to sum. And then we're going to add 1 to sum and 2 to sum, and then add 3 to sum, and sum gets to 6. So that is how this row, this loop is walking across that row, because in this call, game has the value of 0. So we're walking across the 0th row of this two-dimensional array. If I let this continue and come the next time we're stopped, now game is 13 and sum is 0. As we walk across that way, sum gets the 130 and then we add 131 to it, and it becomes 261 down here, and so on and so forth. So my test passed because I calculated it correctly. So to calculate the passing yards in a given game, so a given row of the array, we hold the row constant and we loop across the columns. Okay, let's do the same thing, but let's do it in the other direction. So now I want to build average passing yards per quarter. I'm going to pass in the same data. Oh, not num quarters, num games, num quarters. But this time, instead of passing in a game number, I'm going to pass in a quarter number. Yeah, they're both integers, but they mean something very different. And what I want this function to do is you're given this array and you're given a quarter number. So say we passed in 2 as the quarter. I want it to walk down and add up all of what happened in the third quarter of the game and then divide by the number of games so that we get the average number of passing yards that happened in that quarter of some game. So where the first one was walking across a row, now this one's going to walk down a column. I'm going to play a very similar game for how we start things, but the math becomes a lot harder because there are 14 of them instead of 1. Oh, I want average. Yeah, just let it type it. Why are you thinking so hard? Pass in the season, pass in quarter number 0, and then I don't want to do the math. I have the data here. The sum of this is 910. So if I add up the 0th quarter, I should get 910. When all else fails, don't think. Let Excel do the thinking. And then in my stats.c, I need to build that. And in the beginning, just make it return 0. Whoa, return, spelled like John. There we go. And this should fail because I haven't built anything yet. It does fail. And in fact, it fails on the test that I just added. Yay. So the easiest way to make that test pass is to hard code that 910. Woohoo, that passes, but I didn't actually build anything yet. But I like green. I like passing better than failing. I want to do the same thing, but do it in the last quarter instead of the first quarter. And that means that I want it to go down this column, and the total for that column is 952. 952. And that should fail. Yay. And there's actually like a reason why in this one I picked game 0 and game 13. And in this one I picked column 0 and column 3. I'm doing the ones on the edges. Remember we talked about border cases where a border case is 2 values where the behavior of the system changes. In an array, the places you need to be most afraid of are the very edges of the array. And essentially the border case is the edge of the array and past the edge of the array where it works and it doesn't work. But I'm not doing any error checking on this. So I'm not testing that if you pass in something bad, I do something bad back at you. So instead, I'm just testing to make sure that I can get to all of the edges of my array. So when I was testing yards per game, I tested this game and this game because they are the extremes of the array. And now that I'm testing average passing yards, I'm testing this column and this column because they are the extremes of the columns. Okay, so now we fail because I hard-coded that 910. So essentially, I need to do the same kind of thing that I did here, but I need, instead of walking across the quarters, I need to walk across the games. So I want to start at game 0. I want to go all the way up through number of games, and I want to increment the game number. And so notice this time, this line of code is exactly the same as this line of code. The difference is in this one, I'm holding the game constant. I'm varying the quarter. That's what's making me stay in one row of the array and walk across it because it's the column number that is changing. Quarter is the one that is changing. In this one, this code is exactly the same, but this time we're holding the quarter constant and we're changing the game. So I'm holding the column constant, changing the row number. That's making me walk down that one column of the array. And then, oh, I said this would be average, and this whole time I've been coding it as if it's a sum. Let's fix our tests. It should be this divided by num games if I want an average. And that would do integer division. And if I have an average, I really want the fractional part. So I'm going to force one of them to be a double so that I do real division. All right, now that's an average, not a sum. Those are much better tests. And now the world should crash and fail. And it does. The first one doesn't pass because I didn't divide properly. So here I have my sum. I need to divide by my sum by number of games. And do the same trick to make sure that it does real division. Why are you mad at that? Narrowing. I am not narrowing the conversion, Clang Tidy. I am raising the conversion. We're just going to tell it. We're just going to ignore that. I'm not sure why Clang Tidy is mad at that particular typecasting because it's a really normal typecasting, kind of exactly like what I did here. So I'm not sure why Clang Tidy is mad at that. It's wrong. Now, if I pass that, everything passes. And so there's some interesting lessons to that. I did not write the code linearly. Like I didn't write it from top to bottom, like you would write a paragraph or something. I stuck some here and stuck some there and tried to do the easiest thing I could do because I like it when things are all passing. But then this technique of having 2 tests for each function is called triangulation. Because basically the only way to really make that work is to write the code that would work for all of the tests. And be very aware that while I gave you a strategy of test the edges, the auto grader is going to test the stuff in the middle too. So you can't like hard code solutions for just these 2 cases. You need to write the solution that is actually looking at the data. And the auto grader is going to give you a different set of data than this set of data. So you can't pretend like you know the data when you're over here. Okay, so that would be rectangular arrays and how you walk across a row or down a column. Now, in real football games, this rectangular array thing doesn't really capture what we want because some games we have overtimes. And so that means that there's more than 4 quarters in some games. And sometimes, you know, there's terrible lightning at halftime and they call the game and the game only has 2 quarters. Or there are some weeks in the season where you don't play and therefore you don't have any quarters. So I could, in theory, just say, well, let's just pretend that every game has 6 quarters in it, because that would let us have 3 overtimes, and very few games ever go past 3 overtimes. And, I could fill in with the same kind of data here. But my trouble is, if the first game has no overtimes, are these 0? Or is one of them like I didn't use this and I didn't use anything past it? Or does 0 mean the game wasn't played? Or we played this quarter and we just weren't very good and didn't complete any passes, so the 0 is something actually happened. So when the games do not have a fixed number of quarters, this rectangular array solution is a really awkward solution. So instead of that, what I would like is games that have extra quarters in them have data in them. So that one had 2 extra quarters because 2 overtimes. This one has 1 overtime. This one has 3 overtimes. Whatever it is. We would like each game to be able to have a different number of quarters. And this one, there was lightning. Instead of being a rectangular array, that's a jagged array. To deal with a jagged array, we need a different solution. I'm going to store things in a different way. For good measure, let's put a breakpoint right here and stop so that we can look and see our rectangular array, what it looks like in memory. The debugger makes us think that it looks like this. But if I go to the actual memory and I dump the stack, in here you can see here is row 0, row 1. It just so happens that the rows are 4 and the memory gets dumped in 4s. But basically, you can find the data in somewhere down here. There, I guess. You can find the data in memory because I know what data I put into that array. So I can look for it and I can see it. That's not going to be when we build the non-rectangular one, the jagged array that looks like this. It's going to look different in memory. So the rectangular array actually gets stored as a one-dimensional array, and the row major order magic makes it feel like it's a 2-dimensional array. Now I want to take all of this and I want to build a jagged array version of this. So I'm going to create another runnable main jagged that is a C file, and I want to make a new target. I don't add it to that. Add an executable jagged. Okay. I think it's already there. So now, oh, it didn't add it. Okay, I'll make my own. I'm making a separate executable jagged array main that has that. And once I load this, then I can pick, do I want to run the jagged version or the not jagged version? So I'm going to close these because I don't want to look at the old code. My main jagged is here. I need it to have a main function so that it's runnable. I'll start out just making it print something so that we can be sure that what I did with the CMake really works. And now if I go up here and I say I want to run Jagged, it runs that and I see Jagged. So what I've done here, because the structure of my data is going to be completely different, I want the tests are going to need to be different because the data that I'm looking at is different. And the implementations of those two functions are going to be different because it has to deal with the jagged array. So I'm just creating a whole separate set of files to deal with jaggedness, and then we'll be able to compare them to the files that deal with rectangular arrays. Okay, so I want to create, not there, I want to create a new C source file that is a C file. I'm going to call it jagged stats. And I want it to go into the jagged array executable, and I want the header file to be made as well. Okay, sure, do the thing. And so now if we look at my CMake, the jagged one, oh wow, look how terribly I typed the name of that. Yikes. Let's see if I can fix that easily. Rename the file to not have a closed parens in it. Oh, very nice. It renamed them all for me. Excellent. Okay. So now I've created the same kind of 3 files that I had created before, but now I have jagged versions of them. I want these same kinds of functions. Well, before I do that, maybe I should figure out how I'm going to build that array. The jagged array is actually much, because we do not yet know how to dynamically allocate memory. The jagged array is actually pretty gross to code because I want it to look like this. I'm going to see if I can copy and paste. Yeah. And just for giggles, to make sure we did this correctly, %d, if we were to print out season game 13 number 1, we should see this 131. Let's just see if I did that properly. I did. Woohoo! Now will you format the file for me? I can go to code, reformat file, the whole file. And look at that. It like lines everything up and makes it beautiful. Okay, that was terribly tedious, and I fast forwarded through it because it's really ridiculously stupid. But now I have a 2-dimensional jagged array. There's these are the rows. Each row I defined individually, and then I put them together into the 2-dimensional array like that. And so this jagged array looks exactly like, has the same data as this jagged array. But if we stop and look at it in memory, it is not the same pretty that the rectangular array was. Because if I look at it here, if I look at season, yeah, it shows me all the things. It can't go into them because the definition of season just is an integer pointer. So it doesn't know what's past that. You and I know that this is season 0, and I can see that data here. But the debugger doesn't know that here. And if I go to the memory view and I dump the stack, I can see here is row 0, here is row 1, here, 14, 15, 16. Here is row 1, here is row 2. Where is one that is larger? Row 4 should be larger. 4, 6, 4, 7, 4, 8, 4, 9. Yeah, this is larger because the numbers go past. No, they don't. That's a lie and a half. 0, 1. Ooh, should be able to find this. The 1. Oh, it's right away. This is the one I'm thinking of. It should go through 15. So we see 0, 1, 2, 3 there. Then this is 14 is 20. So that's 20, 21, 22, 23. See, it's put them in like not the same order. The one that is 10, 11, 12, we should see one that starts with A. And we see it here, A, B, C, D, E, F. So the compiler has chosen not to put our rows in sequential order at all. And our season is actually all these pointers. So the row 0 is at, be careful, not there. Row 0 is at 450. So row 0 is at 450. So this is row 0. Row 1 is at 510, which is way down here. That's what we thought. Row 2 is at 460. So row 2 is here, and that's 20, 21, 22, 23. So instead of being stored consecutively row to row to row to row to row to row, it has stored each of the rows independently in random order that it has optimized based on the structure of the cache of the processor. And we don't need to go into that right now. And then it put them together by making an array of pointers that point to them. So when it's a jagged array, it's an array of arrays. Each row is an array, and then we put them together in another array. So that's what we have here. The only other challenge that we have, if this is going to be our data, is how do we know how long each season is? Because now each season is a varying length. So where I used to be able to walk each season is a varying length. Start over. How do I know for each game how many quarters does it have in it? I used to be able to say there were 4 quarters in every game when the season was rectangular. But now every game has a different number of quarters. So I'm going to need an array, num quarters, that is num games long. That is, there are 4 in game 0, 6 in game 1, 4, 4, 5, 4, 4, 4, 4, 7, 2, 4, 4, 4. So I just walked down these because these were in order. There are 4 in the 0th game. There are 6 in the 1th game. There are 4 in the 2nd game. Yada, yada, yada. We should see, the weird numbers we should see is the 4th game should have 5, and the 9th game should have 7, and the 10th game should have 2. So now the way that I know how many quarters are in a game is not a hard-coded constant. It is this array tells me how long each one of the rows in my jagged array is. So this is the data. And I've made gobbledygook test data. In a real system, this would be what happened to some particular team during a particular season. We would fill their numbers in for this. But I needed test data. So this is my test data. So given this, I want to compute the same 2 things that I computed before. I want to compute passing yards per game and average passing yards per quarter. But I need to do it for this new data set. So I still have the number of games is 14, but I'm going to have to change the parameters to these things because I need to give it slightly different information. I can't say that there were 4 quarters in every one. I can say I know how many games there are. I don't know how many quarters are in each one. I think that'll work. But if it doesn't work, we'll come back and play with it again. This is one of those, the syntax of how you pass jagged arrays around is different in every language. I think this is right for C, but if it's not, we'll fix it in just a minute. In addition to passing in the season, I have to pass in the number of quarters array as well. And for now, let's forget about the average one. Well, I commented that out so that the compiler won't get mad at it for now. I'm just going to start out by building passing yards per game. And so I need to build some asserts to test that. I could assert that if I call passing yards per game, passing in my season, and I could spell season better and it would not be red. There we go. And my number of quarters array. And then let's start with, just for giggles, game 0. Or, yeah, game 0. Passing out. So that should be the sum of these, which once again is 6, just like it was the last time. Import. Whoa. Oh, they're not, they're equal. I'm coding in Java. There we go. Now it's mad that I'm passing in, yeah, over here, I want this to be an int pointer data. The same way we declared season here. That's what my 2-dimensional array is going to look like. So it's a pointer to an integer array. It's an array of integer pointers. I'm not sure this is going to help you all at all, but I'll keep going. So now I need to build passing yards per game. And we think, you know, it ought to look kind of like passing yards per game here looked. Because we're trying to do the same thing. We're trying to add up a row of the array. Oh, I didn't copy the whole thing. Do that again. Copy the whole thing. Yes. But I want its declaration to look like this instead of what it used to look like. Because I need to pass in the number of quarters information because it's not a constant. There. Okay. And I need to make sure that my test fails. before I actually write the code. My test fails. Okay, good. I can make it pass really quickly by doing that. But now that 6 just feels too gross. We're too far into this. I'm going to go back to returning some. And I want to do this kind of thing, but I know I can't do this num quarters thing because not all of them have the same size. Instead, I need to go to the number of quarters for the game that I'm working on. Yeah, okay, Clang Tidy says this could be a constant because I never change it. It's right, but I don't care. That's not something that we have talked about at this point, so I'm just going to ignore that warning. So what this should do is it should run, because I'm passing in game 0, game 0 looks like this, and it has 4 quarters. So it should walk across those 4 values and sum them up and get a result of 6, and that test should pass. Okay, that test passed. And actually, I have coded it correctly now, but it really feels like I need to play with one of these weird ones that has a different length and make sure that something with a different length works. So I'm going to do this again. And instead of asking for game 0, I'm going to ask for game number 4, because game number 4 has a different length. And I want to make sure that it's really going all the way through all of the quarters, not quitting without going into the overtimes. So game 4 should be 40 plus 41 plus 42 plus 43 plus 44. Oh, lovely, lovely pluses there. So if I have coded this correctly, when I pass a 4 into here, it's going to use, the loop is going to go all the way to num quarters sub 4, and num quarters sub 4 is 5. So that's what's going to make it go further than the 4 quarters. So that's what's making it go into the overtime. Works. Ooh. Okay. We have one more thing that we need to do. We want to do the same average passing yards per quarter. I need to fix the way I passed this in. And I need to also pass in the num quarters data, because in the jagged array, like if we look at our jagged array here, if I pass in quarter number 0, I want the sum of these things divided by 14. But if I pass in quarter number 2, I want the sum of these divided by 12, because there are only 12 games that went that far. And if I asked for quarter number 5, I'd want the sum of these two divided by 2, because there are only 2 games that went that long. So let's code those 3 tests. So the first one is, if I do column 0, column 0, that should give me this divided by 14, which is 65, 910 divided by 14. Oh, I knew that from before. Whoops, I should have remembered that. Oh, well. And then let's do the third quarter. The third quarter. And that should be, no, not the third. The third quarter is quarter number 2. That should be this sum which is 836 divided by 13, because only 13 games got all the way to the third quarter because there was lightning one time. And then I want to do, I'm tired of typing. Let's copy and paste this. And instead of column 2, I want to do column 5 and make sure that I get only these two. So quarter 5 should be 15 plus 95 divided by 2. Yeah. Okay. I run the test. The test fails miserably. Oh, these are all going to do, we need to do the double thing here again. Because I need to make sure that it does real division. Okay. Undefined reference to average passing yards per quarter. The compiler is complaining about down here. That's because I didn't make one. No wonder it's mad at me. I want this declaration of a function. And we think that it's going to be kind of like this one. It's going to look kind of like that. Well, for now, let's just return 0 and get our tests to fail. It fails, and the first one that fails is looking at season 0. Season 0. Quarter 0. Thank you. So now we think it's going to look something like this, where we have a sum and we're walking down the games, and then we want to return the sum. But the trouble is that sometimes I can't do this because a particular game might not have the quarter that is the column that we're running down. So in here, I need to check to see if num quarters of the game that we're currently about to add in is greater than or equal to the quarter that we're looking for. Greater than. Let's think about that. This is how many quarters there are. So, for example, in this one, there are 6 quarters. Did I code that right? 4, 6. Yeah. Number of quarters. Okay, I did that right. So, if I was doing quarter 5, I would need the number of quarters to be greater than the quarter number that I'm working in. So it's actually clear if we think about this one. If I'm asking for quarter number 4, for this game, the number of quarters is 4, but I don't want to use it here. So the number of quarters has to be greater than or equal to the quarter that I am looking at. So the number of quarters has to be greater than or equal to the quarter that I'm looking at. So if I pass in a 4, no, off by 1 errors are funny. If I pass in a 4, I do not want games that have 4 quarters to count, because this is actually the 5th quarter because we numbered them from 0. So I want the number of quarters has to be greater than the quarter that I'm looking for. Because this, so let's do this. Let's do num quarters. If we were like, just to like make a point here, the number of quarters for game 0 is 4, 6, 4, 4, 5, 4, 4, 4, 7, 2, 4, 4. So when I'm trying to sum up this How many in the first overtime, which is quarter number 4? The only games that I want to count are ones that have num quarters greater than 4. So I want to count this one and this one and this one because they have data in the fourth quarter. So their number of quarters is greater than 4. So if the number of quarters is greater than the quarter that I'm about to sum up, I want to include it. And you think, like I just spent a whole pile of time thinking about, is this greater than or equal to? It's normal to have to think about that for a bit and to draw a picture and play with the numbers yourself to decide, is it a greater than or equal to? The other thing is I used to divide by the number of games, and I can't do that anymore because not all of the games might have added to that sum. So I also need to count how many games added to that sum. So every time I add to that sum, I need to make counts get bigger by 1. And then my average is the sum divided by the count. Whoa, that didn't work. Cool. Really, you're not going to let me scroll? Oh, you are. Okay. So it says that when I passed in a 2, I did not get 836 divided by 13. Let's first check to make sure that 836 divided by 13 is right. Because, at this point, I don't know if the test is wrong or the code that we wrote is wrong. So first I'm going to look and see, is this 836 divided by 13 correct? When I'm thinking about quarter number 2, that's this quarter. So I wanted to add up all of this data, and Excel tells me the total of that is 836, and there are 13 in it. So the average feels like it should be 836 divided by 13. So the test kind of feels like it's right. So I'm going to put a breakpoint on that test. Run it in the debugger. There we are. I'm going to step in and watch that work. So I step into, here I am in my thing, in my code, and I step over sum is 0, count is 0. We're looking at the 0th game. We would expect the 0th game to add a 2 to sum. So sum should go from 0 to 2, and it does. That's lovely. And count should become 1. Okay. And that should keep happening all the way down till we get to 10. Like 10 is where something's going to go weird. So let's watch while the game is 1. And we got to 14. That's right. Okay, so we're doing okay. I'm going to go till game is 9. And look, when game is 9. Game is 9. At this point, my sum is 470. Is this 470? It is 470. Perfect. So the fact that this is 470 at this moment makes me feel good. When I step over this, now game is going to be 10. This is a weird one because this is the one that should not get added to the sum. If we look at quarter is 2, game is 10. If we look at num quarters sub 10, I can't look at it there, but I can look at it in the main function. Num quarters sub 10 is 2. Okay, so that feels like that's right. If I step over this, does it not add? It did not. That was perfect. It did not add the one that it was not supposed to add. And then it adds the 11th one, and it adds the 12th one, and it adds the 13th one. So at this point, our sum is 836, and our count is 13. That feels right. 836 divided by 13. Didn't my test say 836 divided by 13? Why would that test fail? Somebody must be doing the division differently than the others, because if I do step over and step over, that's where we fail. Okay, so it looks like everything is right. My guess at this point is that something's going wrong and Clang Tidy's actually bitching about something it wants to bitch about here. I'm going to printf inside. So I'm going to make it do the math. Well, actually, I can do better than printf. I can say double average equals this. I can do that there and return the average. So that way, when I put a breakpoint here, I'll be able to look right at what's happening. And in my main, I'm going to make it spell better than that. The expected value is this. So I'll be able to compare what's in expected to what's in the average and compare them. Oh my goodness. Clang Tidy was bitching about something important. I'm a moron. See where now it says narrowing the conversion from double to int, and I couldn't explain before why it was worried about it in that order. It's worried about it in that order because that says int. So, you know, if I put a breakpoint here and restart it, I'm going to show you why this is doing what it's doing. That's when we called with quarter equals 0. I don't care about that one. I'm going to keep going. Here we are. We're about to call it with quarter equal 2, and the expected value is off the screen. I don't know why it's off the screen, because it's being stupid. Oh, because this is not hiding. There we go. 64.307 is what it's expecting. When I continue to this breakpoint, 64.307, that looks like they're the same. So it looks like I'm doing everything perfectly, except when I return average, it's converting it to an int. It's truncating it. So when the return value gets back, it's going to be just that 64, and that's why the assert fails. If I make this double, and that means I have to also make it double here. Okay, and then if I were to run my things, all the things pass. So the lesson here is, when I first said I can't explain why this is doing this, I thought it was complaining about the typecasting. It really should have put this like squiggly line under the whole thing, because then I would have seen this also should have been double, and this should have been double. And then I can check to make sure if I run the original rectangular one, it passes. If I run the new jagged one, it passes. So that would be how I would write code for rectangular arrays and jagged arrays. We're going to have a conversation about how valuable is this. Okay, thanks, bye.